let us take one more application. Elimination in alkyl halides or in alcohols can be studied with reference to this stability of the alkenes, wherein a rule called a Sedgwick rule. We are applying in the elimination principle, this rule we are applying. In this rule, if alkyl halide is taken, for example, if 2-chlorobutane is taken, this 2-chlorobutane I am doing what? Minus of HCl. So, H can come from that side or from this side. In fact, there is a hydrogen on the same carbon also, but if the HCl is removed from the same carbon, that is called alpha elimination, which will give a carbene. So, always Cl takes from the next carbon, either that side, another chance is there this side. So, there are two chances are there, chance 1 and the chance 2. If that side elimination takes place, you are going to get the 1-butene. If this side elimination takes place, you are going to get the 2-butene. Now, the question is, which of these two will get as a major product, or will you get the same equal ratio? That is the question. Now, the rule says that whenever the HX, this is H and this is outgoing, this halogen is said as a X. So, whenever HX is eliminated, H comes from the beta carbon of the X, beta carbon means next carbon, either that side or this side, where number of hydrogens are less. Here 2 hydrogens, here 3. So, the H comes from the less carbon, less hydrogen side. So, X is the same one whenever HX is eliminated. So, H comes from, so short definition I am giving, H comes from less hydrogen side. That is always beta only, okay. So, H comes from the less hydrogen side. This side 2 hydrogen, that side 3. So, the rule says that whenever HX is eliminated, H comes from the beta carbon where number of hydrogens are less. This side 2, that side 3. So, 2 side is preferable. Second chance is more preferable. That is, this is first chance, this is second chance. Second chance is a major product, he says. However, when he was defining this rule or observing these cases, at that time probably he had no idea about the stability of the alkenes and all that, but later it is identified when once this hyperconjugation is the phenomena and all that values calculation will become now can be better explained through the hyperconjugation. So, in the second chance product is 6 hydrogens are there, right. In the first product, only 2 hyperconjugations. So, the rule only says which is major, second one major, but the hyperconjugation says why it is major, because it has more hyperconjugable hydrogen, more stable, that is why it is formed. So, many times as I said, which product is formed out of A and B means the stable product will be formed. So, this is the stable product, therefore formed over this. Why it is more stable? More hyperconjugation. Hyperconjugation is nothing but a resonance type. So, 6 resonances versus 2. So, this is the more stable one, right. So, 2-butene will be always a major. You can also, the percentages also some extent you can apply. The ratio of this will be the 2:6 means 1:3, that is out of 4, 1, that is 25% and 75%. So, percentages also you can guess and verify with the data, practical data means almost it is coinciding with a small practical error, but 1-butene is formed 25%, 2-butene is formed 75%. So, therefore, we are able to guess even the percentages also, not only the major one, but almost percentages also you can guess, because based on the available hydrogens is the criteria for this calculation of percentages also.